Welcome. Thank you for joining us here today at Crystal Instruments for this overview of the Crystal Instruments Vibration Control System. My name's Darren Frazier, and I'm the Vice President of Sales here at Crystal Instruments. We're putting this overview together for you today to give you a better sense for both the hardware and software that we offer on our single-axis and multi-axis vibration control systems. Throughout this video, we will cover the Spider ADM hardware, including the features that make it a leading hardware platform for vibration control applications. Finally, we will provide a live tabletop demonstration of the system running in both a single axis and dual axis mode. We will couple two shakers together to provide a more authentic situation that may be found in a laboratory setting. For this segment of the Spider ADM overview, we will talk about the Spider ADM hardware platform. That is the system we have here. This system has 8 outputs and 56 inputs. Those outputs can drive up to 8 independent shakers at one time. The inputs each sample up to 102.4 kilohertz and have Crystal Instruments' own unique dual A to D converter design on each one of the inputs. That's two 24-bit A to D converters per input, giving the user an allowable dynamic range of up to 150 dB full scale. In addition, we have an external storage device for a solid-state storage expansion, as well as a digital LCD screen to give the user input on the current state of the system. Thank you for joining us, and please let us know if you have any questions on the content you are about to see by reaching out to us at info@go-ci.com or by contacting your local distributor.
Hello, we're going to run the MIMO sign control on a dual shaker setup. So here, 2 shakers are set vertically with a beam structure rigidly mounted on top. A couple of sensors are set as control, and then a couple of others are set as measurement. So here is a MIMO sign test setup, and let's look at the setup first. So let's check the input channels. So here we have 2 control channels, and each labeled with a control label. Here we use Z1 and Z2, and the others just set as monitor channels, and the IEPE are set to give the sensor power. So that's basically the input channel setup. Let's say OK. Let's look at the config for the major setup parameters. So the first one is the shaker parameter. Here for the MIMO control, multiple input, multiple output sign test, we need to set up a shaker configuration. So for this case, a dual shaker vertical setup is used. Here, the drive side also labeled as Z1, Z2. Now we have multiple drives to handle. So that's the shaker configuration and some other parameters. If we look at the test parameters, that's very typical for the sign test, very similar. And we use tracking filter typically for log sweep, proportional tracking filters used. Pretest, very similar to the other MIMO test type. So uniform random, burst random with different block size. Here I want to mention that the sequential pretest is important for this rigidly mounted structure. And also say we can use multi-resolution for the pretest. The idea is to have a much high frequency resolution for the lower frequency portion. So that will provide the better control when it's running the low frequency sign control. So multi-resolution, keep in mind that could be very useful. Test profile. Here we have two profile to control, and for this case, we will use magnitude and phase. So the profile will specify a 1G 500 Hertz sine profile, and both using the same profile since the structure is rigidly mounted on top of the shaker. And we want also the second control channel has the zero phase with respect to the first one. That literally means both control channel will go together, so they are in phase. And run schedule, here we set up one sweep from 10 Hertz to 500 Hertz and running through one, so it's going to take about 2 minutes 49 seconds. So that's the setup. Now let's try to run the test. Hit the run button, so the test will be initialized, and then it will bring into the pretest mode. For pretest, a MIMO random type of test is used. The idea is to get the system transfer function matrix. So here, remember we use the sequential pretest mode, so one shaker will run at a time, and after both shaker run, it will construct the system transfer function matrix, and that will get the test ready. So here it's ramping up with the first drive. I'll say the first shaker is running, and so we can see some signals. And the first one measure the noise. Since this is 500 Hertz and with relatively large block size, each frame will take a bit longer time. So this pretest take a little bit while. So let's wait the first shaker running to finish, then it will count the second shaker running. So since one shaker is running, so on that side, the sensor will be the major one to have relatively high level, while the shaker on the other side will have relatively low level. So that's from the spectrum wise. And also we can look at the transfer function. Because one shaker is running, so we construct two transfer function from two control channel versus the first drive. And it's still running on the first shaker. And once the second shaker has been running, so the two transfer function will be added to the display. So then for the whole system, it will have the 2x2 transfer function matrix. So here we see the second shaker is running now. So we see the drive, and then we see the transfer function from the second shaker or the second drive part is being added. So that will construct the 2x2 or say 4 transfer functions for this system. Okay, we will be almost there. And similar situation for the response spectrum, because one shaker is running, so the other side has the high level compared to the another shaker end. So give it a little bit of time, and we'll conclude the pretest. Okay, pretest is done. So now we look at this, everything's ready, so we can hit the proceed button to start the sign test. So now the test will be called back into the MIMO sign type, and it will be started to test. So initializing the system, and then the dual shaker sign test will be started. Okay, so we can see the both control ramping up, and I can see the shaker is moving since it's 10 Hertz, and it's ramped up. Now it started sweeping. So we can see the constant displacement session, and now it's ramping up and sweeping up 13, 15 Hertz-ish, and we can see the control follows the profile very well. on both. And so for this total, so remaining 2 minutes ish, so we will let the test go. That and very good control. And we can feel the table is kind of also shaking as frequency goes. So both drives, they are kind of similar to each other. Okay, about 40 Hertz-ish. And here the table is moving, so that's some kind of resonance of the table, so that's caused the control a little bit up and down. But let's look at the time domain signal. So let's look at block 1 and block 2. So here we can see the both control channels, they are in phase, and the controls very well sine waveforms. So because in the profile tab, we say control them to be the same magnitude and also their phase to be 0. So both control channels, they have the same phase. That's very important for this rigidly mounted dual shaker setup. Okay, so I will let the sweep go a little bit while, then I will stop it. And so that's basically, yeah, the MIMO dual shaker sign test. Hello, in this video, we are going to look at the MIMO random control. And here we have 2 shakers, and they are set up vertically, and the rigid beam was mounted on top of dual shakers. And this is the software launched with the GUI very similar to the single shaker control. Let's look at the setup first. So the first thing we look will be the input channel settings. So here with this setup, I have 2 shakers and also 2 control channels. So the other channel can be monitor channels. So with 2 control channels, there's a control label, and here Z1, Z2 are used to label these 2 controls. And the profile will be assigned using these labels. So everything else will be the very similar or to the common ways. Let's say OK. Let's look at the configures. So here, the first configure is called shaker parameter. With the MIMO control, multiple input, multiple output settings, we have a shaker configuration setup. So for this case, the system has the dual shaker setup. So they labeled from the drive side as also Z1, Z2. So that will be labeled for the drive signals. And you can save your configuration files and use it later on with also other test types. So the other test setups are very similar to the single shaker control. Let's have a quick look at the setup parameters for the test. So here, H update ratio for this case, it's set to 0 because the structure, the beam, is rigidly mounted on both of the shaker head. So with that correlated, and also we try to control the both control channel to be in phase. So with this correlated target, the drive will be correlated. So update H would be cause some issues. So we set to 0. Pretest, it's very common and we can use in typical, use uniform random or burst random can be used for some cases. And so with 16 average with certain target levels, so that's the parameters for pretest. Here, the use sequential pretest is checked. The idea is with the rigid mounted structure, so we don't want to run the both shaker or multiple shaker together because they are open, so they could have some rotations in this rigidly mounted structure and cause some damage. So sequential pretest could be used. The idea is it will run one shaker at a time, and then the other shaker will be forced to be moved following the main shaker which is moving. So which reduce the chance to damage any structure or even the armature. Test profile, for this case, 2 profiles assigned, and since it's vertical, same profiles are used, and it's rigidly mounted, and we use the magnitude and the phase control, and the phase for the second one control is the same as the first one, so the phase is 0. So both control channel will go together, and they are correlated. Run schedule is very typical, so we will run from -6 dB for 20 seconds and -3 dB 20 seconds, and then 5 minutes on 0 dB. So that's basically the major setup, and we're ready to go to hit the start button. Okay, so let's back to here. Let's hit the run button. So the first thing will be the pretest. So with the pretest, since we choose the sequential pretest, so one shaker will run at a time, and then the second shaker will run. And by doing that, the FIF matrix of the shaker system will be constructed, and then we can start the real test. So here, the first shaker is run finished, and now second shaker, so we can see the drive Z2 is outputting, and it has the signals acquired. And once this is finished, and the system transfer function will be constructed. So by running 2 shakers individually or say sequentially, we get this 2x2 FIF matrix. So 2 major ones and 2 diagonal ones. So that represents the whole system. And with that ready, the expected drive will be indicated for this case. And so everything looks good. So we can start we can proceed to start the test. So the test is ramping up, and we can see it's almost there. So it's a pretty good control. So -6 dB. And here, since we choose H update ratio as 0, so the H is fixed. So that's the H, or say transfer function matrix measured from the pretest. So here are both drive signals, and we can see due to the shaker characteristics, they are not exactly the same, but they have the similar trend. And both controls, they're under control pretty well. Now we are at -3 dB, and in maybe 10 seconds-ish, we will go into the 0 dB. And we can see the controls really good. And so we will let it go for a little bit while and look at the control signals. So very, very good control. Now we are at 0 dB, 16 seconds into the full level, 0 dB. And remember, we set up the control to be in phase, and we use the same PSD profiles for both control channel. So we can look at the block 1 and block 2. So we can see for these 2 control channels, the time domain signal, they are overlaying to each other very well. We can zoom in and we can see, so very tiny difference. And so both channels are controlled in phase, and this is in the time domain. We can see the phase relationship also. So that's basically the dual shaker MIMO random control test, and we will conclude this, and we will stop the test. Thank you. Hello, here we are going to run a MIMO shock test. The device setup is like this. A rigid beam is mounted on top of a dual shaker system, so it's rigidly mounted. So here, let's look at the setup first. So this is the dual shaker shock test, and we check the input channels. So now we have 2 control channels set up. So they each has a sign with a label called Z1, Z2. The others are very similar to the regular test. Let's quickly look at the configuration for the major setup first. So the first one is called shaker parameter. So here we have a shaker configuration setup. With this, it's more like from the drive side. So we labeled both drives with Z1 and Z2 label. So that's from the drive side. And if we look at the test parameter, that's very typical for the shock test. And so the correction rate, that means we'll correct error from one pulse to the next. So we give it a 0.15 rate. Pretest, it's very common, so we use uniform random or burst random. For this case, it's uniform random. Sequential pretest, it's checked because the structure is rigidly mounted on the top of the shakers. So with the sequential pretest, the shaker will run one at a time. So that kind of alleviates the out of phase kind of impact on the rigid mounted structure. So which will avoid to damage the structure or say the shaker armature. Test profile is common, so we have multiple profiles to be set, but we have a checkbox that use one profile for all. For this case, we want both profiles to be the same, so we have that checked. So here we set up a 4G 10 milliseconds shock profile, and with the millistandard 810F tolerance band set. The optimum displacement compensation type is used, so that's the profile side. Run schedule, we will run the load level at -6 dB for 2 pulses, and another 2 -3 dB, then for level we will run 30 pulses. So that's basic setup, and let's say okay, we're ready to run. Click the run button. And so it will start the pretest, which uses the random type of excitation. So the idea is to construct the system transfer function matrix. Keep in mind, we set to the sequential test, so it will run one shaker at a time and then construct the system FIF matrix in 2 steps. Okay, so here the pretest is started, and so let's check out the spectrum. So the first is no output, so we have the noise measured and then measure the spectrum. And in the meantime, the FIF will be computed. So with one shaker, we computed 2 FIF. With the second one, the another 2 FIF signal will also be measured. So still the first one is finalizing, and now the second one comes. So the second drive turns on. So we can see another FIF signal, and should be both, so it's be computing. So with that, we will have 2x2 transfer function matrix. So that represents the shaker's systems. So when everything's ready, we'll proceed to the test. So now it brings back to the MIMO shock test, and it will run the dual shaker MIMO shock test. So a little bit initializing, and we're ready to go. So -2 dB, -6 dB. We see the control follows the profile, a little bit arrow, but we can see from pulse to pulse, the arrow is cutting down, and now it follows very well. And so that's, yeah, we can see control 1 and control 2, both the control signal overlays with that. So now we're at 26 pulses, 27 pulses, and perfect control. So that concludes the MIMO shock test. Thanks.
Thank you for joining us, and please let us know if you have any questions by reaching out to us at info@go-ci.com or by contacting your local distributor.